Hey, sixth grade. Today our objective is I can write expressions that record addition and subtraction operations with numbers. And we're going to start this off with an example that lets us explore using a model to create these expressions. So we have two bar diagrams here, and I want to take one of them and create a bar diagram to show 3 plus 5. So 3 plus 5, in our bar diagram, the 3 would have to come first. So I'm adding two pieces together, and the first piece should look shorter than the second piece because this will be my 3, this will be my 5. I'm going to draw a dark line to separate them. And I'll break this one up into 3 pieces and try and make them look kind of equal. And then 5 pieces over here. 1, 2, 3, 4, 5. So this shows 3 plus 5. If I asked you to make the second into 5 plus 3, there would be 5 tiles and then 3 tiles. So it would look a little different, right? So my 5 would be over here and my 3 would be on this side. I'm going to show that. 1, 2, 3, 4, 5, and then 1, 2, 3. So now you can see the 5 plus 3. Are both of these expressions equivalent? Yes. Both of these have a sum or a total of 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So both of these are equivalent, or they have the same value because they both have a sum of 8. All right, so that got us thinking a little bit. Let's look at example 2. We're going to need 2 more bar diagrams. What if I asked you to show me a number, any number, increased by 2? Okay, well, any number, I'll have to use a variable, a, plus 2. Any number increased by 2. So I'm going to start by having a space on here for any number. This piece will be any number. This will be my a. And then this side of my diagram will be my plus 2. And this is the same if I had 2 increased by any number. So 2 increased by any number would just be flip-flopping them. So now I have a on this side and my 2 other chunks on that side. All right, for example 3, oh, and actually I want to point out before we go to example 3, now if I plug in any number for a, this would still be true, right? So I can say as long as a is the same number for both of these, they would still be equivalent. If I plug in 3, I would have 3, 4, 5, 3, 4, 5. If I plug in 0, we'd have 2 and 2. So it still is equivalent, and the bar diagram still makes sense there. For example 3, it says write an expression to show the sum of m and k. So there are actually 2 correct answers for this, but both of the answers have an addition sign because it says sum. What am I adding together? M and k. Because of the properties we learned, we know that we can switch that order around, and another equivalent answer or expression would be k plus m. And that property that tells us we can flip-flop it is the commutative property that we learned about in a previous lesson. So this is because of the commutative property. All right, so example 4, we have another bar diagram that you need to draw. We have a question over here that we're going to answer in a second, but let's start with this bar diagram. So how can we show 10 minus 6 using this bar diagram. 10 minus 6. Well, the whole bar diagram is 10. And then I need to break this up into 10 pieces. So there should be 5 on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And now I need to show that I'm taking away 6. So you can shade 6 of them. I'm going to put X's. 2, 3, cross them out. 4, 5, 6. And then that'll help me kind of go back in and shade to model that I'm getting rid of these. I'm taking them out. Here's the expression that shows that, 10 minus 6. For this one, could we also use 6 minus 10? Would that also work? No. If we started with 6 and tried to take 10 away, the models would not match, and we would also end up with a negative answer here. So remember, for subtraction, that commutative property does not work. Okay, so this question here actually goes with example 5 in this bar diagram. So how can we write an expression to show 3 less than a number? Well, we could start by drawing a diagram to model the subtraction. Are we taking away from the 3 or the unknown number? We would be taking away 3 from the unknown number. So our entire model is an unknown number. I could pick literally any letter to show a number, an unknown number. So I'm gonna pick N, and I'm gonna make a chunk of this equal to 3. We're starting with some number and then we're subtracting 3. So I could show, like, when I'm using a dark color, that means subtraction. And the expression, if we wrote it out as a math sentence, would be N minus 3, any number minus 3. All right, and we are almost done. We have 2 more examples. So example 6 says, how would we write an expression to show the number C being subtracted from the sum of A and B? Well, we need to start by writing an expression for this chunk here, the sum of A plus B. Okay, well, sum means that we're adding. So I'm adding A and B. You could also write B plus A. Now I have to show C being subtracted from that sum. If you put parentheses around this to show that you do this part first, that's also fine. So this could also be an answer, or this. All right, and then finally, example 7, write an expression to show C minus the sum of A and B. So this one sounds a lot like this one, but actually we're starting with C and then we're taking away what A and B are when added together. So I have to show that we're still adding A and B, but now we're doing C minus all of that. So my C comes first. C minus the sum of A and B. Parentheses are necessary in this example. You have to have them because without the parentheses, only A would be taken away from C. But the expression says that A and B together should be taken away from C. Okay, I'm going to replace these variables with numbers to see if that would be the same as this. So let's make A, B, and C equal to some numbers. We'll say A is 2, B is 1, C is 10. So every time I see C, I'm going to plug in 10. Every time I see A, I'm going to plug in 2. And every time I see B, I'm going to plug in 1. Okay, so here I would have to do what's in parentheses first. So 2 plus 1 is 3, and 10 minus 3 is 7. So here I get 7. And on this side, 10 minus 2 is 8, and 8 plus 1 is 9. So you can see we actually get different answers. And you know from doing order of operations lessons and practice problems using PEMDAS that the parentheses matter. So this is just showing you that the parentheses matter. But for this example, for example 7, this problem is not correct. This is how you would write that expression correctly. Awesome. So you have a quick closing. So I do want you to write this. I want you to write it out using your words, and then when you unpause the video, I'll have example answers for you so you can check your work. So you need to write these expressions using words. So you can unpause and see my answers.